Today we're going to be looking at the 2016 January Gold question, radio contact. So in this question, Farmer John has lost his favorite cowbell and he and Bessie are going to be looking for it. So they're going to go on two separate paths, but they want to stay connected via radio the whole time. So every time they move, the distance they have between them, or the distance squared, is going to be used as energy for the radio contact. So it's going to consume this energy, and what we want to know is what is the minimum amount of energy they can use. So let's look at the algorithm for this question. So the algorithm we're going to use for this question is going to be dynamic programming. So what we're going to do is we're going to use a 2D DP. But before we do that, we're going to set up the program. So since the input only gives me the directions that Farmer John and Bessie are taking, what I'm going to do is I'm basically going to create two lists or two vectors, and what it's going to do is both of these are going to store the values of the locations of Farmer John and Bessie after they go through X number of steps. So what this means is we have our starting locations, and so Farmer John 0 is going to basically be the starting location. And what we're going to do is we're going to have Farmer John 1 as after he moves the first step, so say that's north, then it'd be Farmer John 0 and then moved up 1. And then we're just going to basically store the x and y in two separate values, which is why it's 2D. So we're going to have Farmer John 0, 1 and Farmer John 0, 0. And then we're going to do the same thing for Bessie. So what we're basically going to have is we're going to have two different vectors, and for both of these, they're going to store the current location after Farmer John and Bessie have taken I steps. And using this, we're going to build our DP. So we're going to have two dimensions. The first dimension is going to be the current step that Farmer John is on, and then the second dimension is going to be the current step that Bessie is on. So in this way, what we're going to do is we're going to have dpij, and then we're going to store the minimum amount of energy needed. And in order to get to the value of dpij, what we're actually going to do is we're going to find three main values: dpi minus 1, j, dpi, j minus 1, and finally dpi minus 1, j minus 1. And then so what we're actually going to do is after we find the minimum of these, we're going to assume that Farmer John and Bessie have both moved 1 or 0 steps. And then what we're going to do is we're going to actually add the energy needed at their current positions. And the way we're going to do that is we're going to take these two values. So we're going to take I and j, and then we're going to take Farmer John I and Bessie j. And then what we're going to do is we're going to use these two values and then find the distance between the two. And then we're going to add that to the value of dpij. So in this way, we're going to have dpij holding the value of the minimum amount of energy that Farmer John and Bessie need total. And then at the very end, we're just going to return dpnm. So let's just look at the code for this question. So I've set up the code here. I have my two arrays, so I'm going to have the position of Farmer John and then the position of Bessie. So I've maxed them out to the maximum value, and then I've started reading in the input. So I have n and m, and then I have the current location of Farmer John and Bessie. So the next thing I'm going to do is I'm going to read in the different directions for Farmer John. So what I'm actually going to do is I'm going to create a for loop, and then I'm going to go in range of n. And what I'm going to do is I'm going to read in the instruction. And then just like we talked about, what I'm going to do is I'm going to use this instruction, and then I'm basically going to increment my x and y values based on it. So if it's north, I increment my y. If it's east, I increment my x, and so on and so forth. And then using this, what I'm going to do is I'm going to update the current x and y values for this I. So this is going to give me all of the different steps for Farmer John. And then we're just going to do the same thing for Bessie. So I'm going to read it in, this time with m. I'm going to do the exact same thing. And then at the very end, we have our two values prepped and ready to go. So the next thing we're going to do is just going to be our DP. So I have my DP here, And then what I'm going to do is I'm just going to have dp00 as 0, and then I'm going to loop from 0 to n plus 1. And then for both I and j, I'm going to first check to make sure they're not both 0. And then if they're not both 0, I'm going to go through my 3 main base cases. So I'm going to say, if I'm going to start it at the maximum value, and then I'm going to check the borderlines of I and j, and then I'm going to make it the min of itself and dpi minus 1j, dpi j minus 1, and finally dpi minus 1 j minus 1. So at the very end, I'm going to have the minimum value of the last step. And then what I'm going to do is I'm going to add the distance between Farmer John and Bessie. So over here, Farmer John is on step I, and Bessie is on step j. So what I'm going to do is I'm going to add the distance squared. So this is just the x subtracted squared plus the y subtracted, so your regular distance. And then at the very end, I'm just going to return dpnm. So overall, the code is pretty simple. The idea is mostly in the algorithm and the dp state itself. And once we printed out the last value, that's just the end of our program.